Previously, we'd gone over the basics of our AI behavior trees and learned all about the different types of nodes and even walked through a simple example together to craft a behavior tree for Waypoint and Follow AI behavior. A potential issue with this though, and crafting nodes this way, is that there is a strong dependency or coupling with components that use the nodes that we create. For example, our patrol node has a dependency on the character component and makes a direct reference for the character component that's attached to the character entity. So inside of our onBehave, we can see that we're also referencing the character components get move speed, things like that from our patrol node. Our follow node similarly also depends on the character component to get the characters in range so that we can follow, and of course we also reference the move speed in here as well. Today, we're going to try and re-implement our previous system, but this time we're going to create a little worker NPC that will gather resources for us. Our goal is to build an AI tree that decides when to gather flowers and when to patrol while decoupling the AI nodes from the trees that implement them. So here we are back in Maker, and you'll notice that we changed up the scene just a little bit since the last video. Instead of a triangle, we have a more rectangular path, and we're going to retain the same behavior of our mushroom kind of patrolling our path. The addition we're adding is that in addition to patrolling, we're also going to be checking for these resources. So we're going to have our mushroom walk across and check if resources exist in our scene. And it's going to walk over to each resource and try to gather them. After it gathers a resource, we're going to hide this resource and we're going to add a little bit of delay before it reappears again. So after it gathers all of them, there's going to be a bit of a delay until the resources start reappearing. And until they do, it's going to continue patrolling. When the resources reappear, it's going to pause its patrol action and it's going to go back to try to collect these resources, and once they're gathered, continue our patrol. So that's our behavior that we're going to try to implement today. Here's a couple things that we've done last time, just as an overview. If we check our monster right now and the list of components that's attached to it, we can see that we have our character component that we saw before, and we've commented out this build tree because we're not using it this time. But if you go back, we can see that this is where we have built our tree. So we can have all of the sequence nodes and the follow node and the character range decorator and the patrol node simple and all of this stuff that we've gone over in the last video. We can also see that we are referencing the AI component. So here, our character component depends on the AI component and directly references the AI component. While last time we created a separate component that references the AI component, this time we're actually going to try extending the AI component directly and building out our tree from within the AI component itself. So let's actually remove these two components. So let's remove this component and let's also remove this component as well. And then let's search for the AI component and let's right click on it and we'll click on extend. We're going to name this our AI Gatherer Monster Component. And we're going to save because we are in local workspace and we need to update our local workspace files, and double click to open it up. And in here, we're going to have a little bit of code in here. So we have our onBeginPlay as a server only. The execution space is important. And we're going to initialize this tree from the server space as the server only execution space. And we also have our build tree, and we're going to build our tree in here. So far, this kind of pattern should be very familiar to you. This is pretty much what we've done in the character component. We have our onInitialize and onBeginPlay where we have initialized various entities and values that are relevant to our AI to function. And we're also going to build out our tree here. So we're going to keep that behavior the same, except we're just going to do that from within the AI component itself as an extension, rather than creating an AI component reference like we did before. Back in our Maker, let's create a new folder, and we'll name this Components. And let's drop our newly created component in there. And let's create another struct here. So we're going to go into our scripts, and let's create a struct type. And we're going to name this AI Behavior Tree. And what we're going to do with this struct is that we're going to attempt to create a basis for our new tree. So we're going to have each tree organized into its own structure. And we're going to and we're gonna create the ability to reuse multiple groups of trees. So let's say we have a tree for patrolling, another tree for gathering. We want to be able to reuse those trees in other more complex AI behaviors as well, and allow for different trees to be connected together if we'd like. So we can have two trees connected together under one newly created root node, and we've created our new tree, but we've retained the same behavior. This is our attempt to try to create a more modular system and a more dynamic system. So all new trees will be a subclass of this AI behavior tree that we created here. Let's define our base class here. So let's double click to open this up. And we're going to paste in a couple lines of code here. We're going to have our AI component, which is going to be the reference to our AI component that we had. We also have our root node, which is going to keep a reference to the current root node. We're going to have a method to get the root node. We're going to have a way to add the child, and this is going to be inherited by our behavior tree. So any subclasses that extend from our AI behavior tree will implement this add child, and we're going to see that in just a moment. We also have the build tree. So our base class, our base struct, will not have this implemented. Our subclasses will have this implemented by overriding this. Then we have two methods here. We have a connect sequence and a connect selector. Our connect sequence is going to take our two trees, so the current one and the new tree that is being passed in, to connect to this. We're going to create a sequence node as a root, and we're going to attach them together. Then we're going to create our new tree and set the root node as the new root that we've created and attached our two trees to. We're going to do the same thing with our selector, except this time it's going to be a selector connector as opposed to a sequence connector. If you don't know the distinction between a sequence node and a selector node, I encourage you to watch our introduction to AI behavior video so that you have an understanding before continuing any further. So now we got our base class for our AI behavior tree, and we're going to create two more structs here. So the first one we'll name AI behavior, and the next one we will name leaf node. Let's save this to make sure that it also exists in our local workspace. And what we're going to be doing with these two is that our leaf node is going to be the actual node that our behavior tree is going to reference. So our behavior tree is going to be a collection of these different nodes, and our AI behavior is going to be the actual behavior that's executed within these nodes. So essentially what we're doing is we're going to abstract out the behavior part of our nodes out into their own classes. And you'll kind of recognize this as the strategy pattern if you are more familiar with programming patterns. But that's what we're doing here. So our AI behavior is going to be extended out into different types of behaviors and different implementations of behaviors. And our leaf node is going to dynamically inherit the behavior that it should execute. So that's going to be our setup, and that's the way that we're going to approach this problem here. Let's create our AI behavior script first. So we'll double click to open this up. And our AI behavior class is going to be very simple. It's just going to have our behavior method, and it's going to return the behavior tree status that the BT node type that we learned in the AI development intro video is going to return. So it's going to return the same thing, and it's going to do the same thing, except we're just going to be pulling that behavior method out into its own class. Next, let's open up our leaf node, and this is also going to be relatively simple as well. We're just going to have our initialize function that's going to take in any data and any kind of information that it needs. So first, it's going to take in the AI component that it needs to create our leaf node. So we're going to utilize the AI component create leaf node to create our BT node type. So our create leaf node returns a BT node type, and that's going to be the actual node. And it's also going to take in the behavior. So we're going to utilize the create leaf node's behavior parameter to take in the AI behavior. So remember that we've abstracted out our behavior into its own class, and we're going to create the node based on the behavior that we pass in. So this way we can dynamically create our leaf nodes and define our nodes to have different types of behaviors at runtime, and we can also change out the behaviors if we like as well. Next, we have our get node, which is going to return the BT node type that we've created here. So it's not going to return this class, it's going to return the BT node that we've constructed in the init. So saving everything that we've created so far, let's return back to our maker. And let's hit Control R to refresh our maker and synchronize our local up into our maker here. And this is required because we are in local workspace and we need to synchronize our changes back and forth. Alternatively, we can right click and click on refresh to do the same thing. Let's create 2 new folders here. We're going to name the first folder trees, and the next folder, we will name this behaviors. And we're going to collect all the trees that we create and all the behaviors we create in these 2 folders here. So with that, we'll create our first tree and behavior. So first, let's extend our behavior here, and we'll right click and we'll click on extend, and we'll name this AI Patrol Behavior. And this is going to be the behavior that our leaf node is going to take in. So our leaf node is going to take in some sort of behavior, and it will be a subclass of our AI behavior for AI Patrol. So the leaf node does not know what type of behavior it is. It just knows that it is an AI behavior and it's just going to execute that. So let's drop this into our behaviors. And we're also going to create a tree. So let's right click and we'll extend our AI behavior tree base class, and we'll name this AI Patrol Tree. And we'll drop this into the trees folder, and we'll save that, and we'll start filling out both of these classes here. Before we open up our new behavior and tree classes, we first need to fill out some new information in our AI Gatherer monster, because our monster is going to inform our behavior and our tree with some information. So what information do we actually need from our monster component here? Well, first we are going to need our waypoint paths. So if we look at our maker scene here, we can see that we have 4 different waypoints. We have 1, 2, 3, and 4. And our monster is going to cycle and loop through each of these points, going round and round. So we need to be able to pass these waypoints in to our patrol behavior so that our patrol behavior can dynamically patrol across different waypoints without having any waypoints or positions hard-coded into the behavior itself. So this way we can make it a little bit more dynamic. And we've done this in the previous more simple implementation as well, except our patrol node behavior required the dependency of the characters to get the waypoints. But this time, our patrol behavior does not actually need to know where the waypoints are coming from. So let's open up our AI Gatherer monster component. Do be sure to make sure to save before you open up any scripts, especially if they're new scripts that you've newly created, because we do have to sync that to our local workspace. Okay, so we'll double click on our AI monster gatherer component that we created earlier. And if you remember, we had our init and build tree set up here. We're going to add some properties in here. We have our waypoints parents that we're going to grab the children of. So that will be this parent here, and we're going to grab all 4 of these children. And we're also going to have a move speed that we can pass into our behavior so that our behaviors know what speed to move at. Let's also create a property for our waypoints. So we're going to create a table to store all of the waypoints that are coming from the waypoints parent. And then from the init, we're going to grab all of the children and convert that into a table and cache them into our waypoints. So our waypoints has all 4 of these children that we're grabbing in init. And that should be all we need for now. We're going to start filling out the build tree method in just a moment, but we first have to have a tree to build out. So let's actually do that. So we've created our patrol tree, so we'll double click to open that up. But our patrol tree needs to know what behavior to implement. So let's actually open up our AI patrol behavior first, and let's fill that out so that we can use this behavior to implement our patrol tree. So our patrol behavior is going to have a bit of code, and we're going to define our various information that we need for this behavior to work, and that is going to be the waypoints that we're passing in from our monster gatherer component. It's going to be first passed through the tree that is going to pass it along to our AI patrol behavior, but we'll get into that when we build out the tree. But we have our waypoints that's coming from our AI gatherer monster component. We also have the target entity that we're also going to define from our AI gatherer monster component as well. And this will be the target entity that we want to actually move across the waypoint. And finally, we have the move speed so that this behavior knows at which speed to move the target entity at. Then we have our behavior that we saw earlier that we're going to overwrite from the base class. And this behavior is just going to have a reference to our kinematic body component. And it's also going to grab our current position from our transform component as a vector 2. Then we're going to do a quick sanity check to make sure the waypoints exist. And if it does, we're going to continue on and we're going to grab our current waypoint, which is going to be the path index. So our path index is going to start at 1, and we're going to grab that waypoint and we're going to grab the transform component of that waypoint. So that will be our target waypoint. And as long as that target waypoint is valid, meaning it's not nil or destroyed or whatever, we're going to continue on and we're going to grab our target position, which is going to be the target waypoint world position as a vector 2. And we're going to calculate our distance vector. So this is going to be a distance vector from our current position and our target position. And we're going to grab the magnitude of that to create our distance vector. And as long as our distance vector has a value of less than 0.2, meaning that we're close enough to increase our path index. So if we're closer than 0.2, then we're going to increment our path index so that we move on. And if our path index has exceeded the number of waypoints that we have, then we're going to reset our path index back to 1, so that this creates an infinite loop between all of our waypoints. Then we have our target position, that is going to be the target waypoint that we set earlier, and we're going to grab the world position as a vector 2, and we're going to set the move velocity to this value that we're going to set up. So we have our target position subtracted by our current position, and that will give us our direction vector. We're going to normalize that direction vector, and we're going to multiply that by the current frame delta that we're passing in from the behavior, and multiply that by our move speed that we've set up from our initialize. So that creates our direction vector, and it's going to move at that velocity. As long as it's running, we're going to return a success. So that gives us our patrol behavior. Next, let's fill out the tree that's going to reference this patrol behavior. So our tree is a bit more simple in comparison, and our patrol tree is going to have a reference to the waypoints, and that will be passed in to the patrol behavior. And we're also going to have a move speed that we're going to also pass into our patrol behavior as well. That gives us all the information that we need for this tree to function. And we're going to pass in the AI component, the waypoints, and the move speed for this tree. We need the AI component to pass into the leaf node. And in our build tree, we can see that we have our leaf node being created. So we have our patrol behavior, and we're going to create our new leaf node. And in that leaf node's init method, we're passing in the AI component that we got from the initialize. And we're going to name this node patrol, and we're going to create a new patrol behavior that we created earlier. So we're going to create a new patrol behavior, and we're going to initialize this with the waypoints that we got passed in, the entity of the AI component, and the move speed. So we've dynamically created a new node that has this behavior, and we've initialized it with this data. And then we're going to set our root node to the patrol behavior's BT node type. Let's save this. And finally, because we now have our tree and our behavior, we have to finally craft our tree using the tree that we created in our monster gatherer component. So for that, it's very simple. We're going to create our patrol tree, and we're going to pass along in the init method our self, which is going to be an AI component type. And we're going to pass in the waypoints that we've got a reference to earlier. And then we're going to pass in our movement speed, which is currently set to 50, but this can be variable in the inspector. So we've got our patrol tree, and now we're going to do our set root node. That's a component, that's a method from within our AI component base class. So we're going to call this, and we're going to pass in the root node of our patrol tree. And that should give us our patrol behavior. So let's save this. Let's return to our maker. Let's refresh to make sure that we have synchronized our local to our maker. And from our monster entity, let's add our new component. We'll attach our AI gatherer monster component, and we're going to create a reference to our waypoints parent. So let's drag in our waypoints right into there and save it one more time for good measure, and let's press play. And if we check our scene, we can see that our monster is successfully looping across our different waypoints. So it's just going to loop across all 4 of those waypoints round and round and round and round. So we know that this is working now. Next, we have to incorporate the tree for our gathering behavior. So let's do that next. So we've got our waypoints working, and we got our mushroom walking around each waypoint and patrolling our little path here. The next thing we want to implement is gathering of the bushes. So as we discussed, our mushroom is going to walk to each of these bushes or berries and start collecting them, after which it's going to begin patrolling. What we need is to create another component, and let's call this component the harvestable component. And this is just going to identify each of these entities as a harvestable entity, and we're going to define some behavior for them. So let's attach this component to all of these items, and we'll name this as harvestable component. And also notice that we have a tag component associated with all of these resources as well. So each of these resources has a tag component, and we have a resource tag associated with these entities. So this is going to help us to identify and tag these entities as a resource type. Our harvestable component is going to define what happens when you collect it and when to reappear after collecting it. So let's save our maker so that we can sync our changes, and let's double click to open up the script. So our harvestable component is going to have a couple parts to it. First, we have our two properties here. We have the can harvest Boolean type, and we have the respawn time. As the name implies, our can harvest Boolean flag is going to determine whether or not this entity or this resource is harvestable or not. While it is harvestable, it's going to be available to be harvested, and while it's false, it cannot be detected as something to harvest. So we have our initialize function setting our can harvest property to true when this is first initialized. So at the very beginning, it's going to be harvestable. Then after it becomes harvested, we're going to set this flag to false so that it can no longer be harvested until such time that we reactivate this harvest. So the moment it's being harvested, we're going to set the visibility to false. Then after it's harvested, we're going to re-enable it or just set the visibility to true again after the respawn time is up. So can harvest set to false when it first harvests. After the respawn time, which is set to 3 seconds when this is first set up, it's going to set the visibility back to true and the can harvest Boolean flag to true as well. Finally, we have our can harvest method that's going to just return a Boolean type of whether or not it can be harvested or not. Next, let's go back to our AI monster gatherer component. And similar to the way that we've set up our waypoints, let's set up our harvestable components or our harvestable entities, aka the resources, and allow them to be cached into a data table like we have here. So first, let's create a property for our resources parent. This is just going to hold the parent of our resources. So it will just be this entity here, and we're just going to grab the children, just as we've done for the waypoints. Let's add the resources property as a table, and then get the children of our resources parent and convert them to a table, caching them into our resources table property. Okay, that's the setup for our resources. Now let's set up the AI behavior for collecting our resources. We're going to make sure that we have saved all of the scripts that we've created, and back in our maker, we're going to Control R to refresh and make sure that we have synced our local to our maker. Alternatively, of course, we can always just manually right-click and click refresh. Okay, let's just organize just a little bit and bring our harvestable component into our components folder. And for our AI, we're going to need a couple new things here. First, let's create some new behaviors. So we're going to right-click on our AI behavior base struct or base class, and we're going to extend this, and let's create our AI condition. And let's create another one. So let's extend again, and let's name this one AI action. And then one more. Let's extend this, and let's name this AI move to target. Let's save this to make sure that it syncs with maker, and let's drop all three of these into our behaviors folder. Okay, so what do these three do? Well, as the name might imply, our AI condition is just going to be a general conditional behavior where we can pass in any kind of conditional so that we know that it's safe to move on past this node into other behavioral nodes. So the condition is going to act similar to a decorator, the way that we've seen in our intro to AI video, but our condition is just going to be a general function that we can pass in as a parameter and just allow that flag of whether or not we are allowed to pass this node or not. The AI action, conversely, is just going to be a general behavior that performs any action that we pass into it. And then finally, our AI move to target is going to be able to move to a certain target. So what we want to do with this AI move to target is to move to each of these berries or bushes and then collect them. So what is the logic for bringing all of these together? Well, our AI condition is going to check whether or not these are collectible. And then we're going to use move to target to move to each of these berries. And we're going to use the AI action to harvest them. Remember, if we check our harvestable component, we've implemented our harvest method to actually be able to harvest this resource. And once we do, we are going to set the visibility to false. And after a certain timer, we're going to reset the visibility to true. So our AI action simply calls harvest, and our AI condition simply checks can harvest. Our AI move to target is just going to have behavior similar to our patrol to move to a certain target. The final thing we're going to need is the AI harvest tree. So let's extend our behavior tree. And let's name this the AI harvest tree. And then we will drop this right into our trees folder. Hit save to make sure that this syncs with our code. Our AI harvest tree, of course, is just going to actually build out the tree for connecting all of these behaviors to the nodes. So our leaf node is going to be passed in each of these different behaviors, and then that is going to be constructed as nodes connected together in our AI harvest tree. So let's start building out this behavior. Let's start with our AI condition behavior. So let's double click to open this up. And in this behavior, we will have a couple things. We have our condition func property, which is just going to be initialized from our init method and take in our condition function. When we initialize this behavior, we're going to pass in the condition function. Of course, if we remember, that will just be our can harvest behavior. And in the actual behavior, we are going to first double check to see if we have a conditional function. If it does not, we're going to return a failure. If we do, then we're going to actually resolve the conditional function. And if it resolves as true, we're going to return success. Otherwise, we're going to return a failure. And that's it for our AI condition. Next, let's open up our AI action behavior. And in here, we have our action function property. And in our initialize method, we are passing in the action function. And of course, remember, in this case, we're going to be passing in the harvest method from our harvestable component. So in the AI action, that method or whatever method that we want to pass in as the action to be executed when we reach this particular node or execute this behavior, we want to pass in that method to this initialize and to this AI action behavior. The actual behavior is going to be very similar to the AI condition. It's first going to check if we have an action function, then we're going to resolve that action function, and we're simply going to return a success. So let's save that. And finally, let's implement our AI move to target. This one is going to be slightly more complicated. We've got three properties here. We got our target, our source entity, and our move speed. All three of these are going to be passed in from our initialize function and just cached. So our source entity is going to be the entity that we want to actually manipulate the movement for. So we want to actually move this entity towards our target. So that's what we're passing in as our second parameter, the target to actually move towards. So again, source entity is the entity that we want to move, and our target is going to be the entity that we're going to move towards. Finally, move speed, hopefully is self-explanatory. It's just going to be the move speed that we move our source entity at. Okay, then in our behavior method, we are going to first check if we have a valid target, meaning if the target is a non-nil entity. If it is a nil entity or if it's not a valid target, we're going to return failure. Otherwise, we're going to move on. First, we're going to grab our target's position, and that's just going to be the world position as a vector 2. And we're going to grab our position, which is going to be a world position as a vector 2. Then we're going to create our distance vector. So first, we're going to create a directional vector, and we're going to create our distance value by utilizing the magnitude of this vector. So if this distance value is less than 0.2, we're going to say that we've reached our target position and we're going to return a success. Otherwise, we're going to move towards our target. So we're going to grab our kinematic body component and we're going to set our movement velocity to a directional vector, target pose minus my pose, which creates our directional vector. We're going to normalize this direction vector and we're going to multiply that by our frame delta and the move speed that we got over from our initialize. And as long as we are moving, we're going to return a status of running. And that's it for all of our actions that we need for this tree. Now that we've got that, let's actually start building out our tree. Let's double click to open this up. And in this AI harvest tree, we're going to craft our nodes using all the behaviors that we've set up so far. Here is the code for our AI harvest tree. We have our table property for our harvestables. And this is just going to be passed over from our AI gather monster component. So this is going to be that resources table that we've crafted in our initialize function. So we're going to pass in this harvestables, we're going to pass in the AI component, and we're also going to pass in the move speed of our character. So the move speed of our monster, which would be 50 in this case. Then we're going to build our tree. And in our builds tree, we have a lot of logic that looks very complicated, but it will make sense as we go over each of the different types of nodes that we set up so far. So first we have our harvestable component. We're going to be looping through each of the harvestables, and we're going to reference each harvestable as a resource entity. So we're going to grab the harvestable component from each resource entity and cache that into a property called harvestable. Then we're going to return the isHarvestable boolean from our leaf node. So we're going to create a new leaf node and we're going to initialize this by passing in the AI component, and we're going to name this isHarvestable with the resource entity name. So this, in this case, would just be mapObject underscore X, Y, and Z. So it'll be isHarvestable with the entity name, and we're going to pass in the behavior of this leaf node, which is going to be the AI condition that we've created. So we're going to create a new AI condition type, and we're going to call the initialize function from that. Remember, our AI condition takes in the condition that we want to check for and resolve. So we're going to resolve this function and we're going to check for the value. And the value should be a Boolean return. So if you go back to our harvest tree, we can see that we have a return value of the harvestable component can harvest method equals true. So this phrase will be the Boolean value that we're returning from this function. So we have that leaf node cached in our isHarvestable. So this will be our isHarvestable node. Then we're going to have another leaf node as our gather action. So we're going to craft another leaf node and we're going to initialize it. Same as before, we're going to pass in our AI component. We're going to pass in the name of our node, which is going to be gather underscore with the resource entity name. And then we're going to pass in our behavior. So the behavior here will be the AI move to target. So we're going to move towards our harvestable entity. So when we initialize this, if we go back to our AI move to target, we're going to take in the source entity that we want to move, the target that we want to move towards, and the move speed. So going back to our harvest tree, we're passing in the AI components entity as the entity that we want to move, the resource entity as the target that we want to move towards, and the move speed that we got passed in from our initialize. So that is our gather action node. Then we have our harvest action node, and this pattern is going to be very similar again. We are creating another leaf node, initializing it with our AI component and the name of our node, and we're going to pass in our behavior, which will be finally the AI action behavior, and that's going to be initialized with the action that we want to perform when we reach this node. So going back to this, we have our initialize that's going to pass in this action function, and it's going to call this function when it behaves. So we're going to pass in our function here, and the behavior is just going to be the harvestable components harvest. So with that, we have all three pieces of our puzzle, and we're going to put that all together into a sequence node. If we want to know the difference between a sequence node and a selector node, I heavily encourage you to watch our introduction to AI behaviors, and that will kind of give you a rundown of the differences between these two. But we have our selector node that is going to be at our root, and we have our sequence node that is going to be connecting all three of these different nodes together. So we're going to do that for each one of these harvestables. So that is going to create a ton of different subtrees for each harvestable entity that we have. And each of those is going to create a little tiny tree. And all of those is going to be connected to this harvest sequence. And each harvest sequence is going to be attached to the selector node. So the selector node is going to have a bunch of little trees connected to it. And finally, we're going to set our root node to the selector node. And that is our harvest tree. So it looks really complicated, but if we go and break down each of the behaviors and how it's crafted, we can kind of understand and visualize how this tree might look. Okay, so now we have all of the pieces together. We're going to finally put them all together in our AI Gatherer Monster component. So now we have all the puzzle pieces ready. Let's piece them together by creating our reference to this tree. So first, let's craft our gather tree, and that will be the AI harvest tree, and we're going to initialize this tree with our self, which is going to be the AI component. We are going to pass in our resources that we've cached in our initialize, and we're going to pass in our move speed, which will be 50, or whatever value we set from our property inspector. And then now that we have both of these two, we need to update this so that these two trees are connected together. So let's update this line. And what we're going to do is we're going to get the gather tree. And remember that our gather tree is an extension of our AI behavior tree. And our AI behavior tree has connect selector and has connect sequence. We're going to connect selector to the patrol tree. So these two trees are going to be connected together by a selector node. And we're going to grab that new selector node and set that as the root node of this AI component. So we've effectively combined our two trees together under a new selector node and set that as our root. And that is our final tree. So let's go back to our maker and let's test this all out. So we're going to refresh our maker. Looks like we have an error. Let's go back to our code and figure out what's happening here. Looks like we missed our void keyword here. So let's save that and let's refresh. And we should be clear of any errors. Looks like we're good to go now. Just for good measure, let's right click and click refresh. Okay, we're still good. And now let's go back to our monster and we need to hook up our resources parent. So let's drag in our harvest root entity so that our AI Gatherer monster can collect all of these children and cache them. So let's press play. And it looks like we've lost our reference to our harvestable component. So let's double click just to make sure that our script is still there. Okay, it is there. And in each of these, we have to attach our harvestable component. So let's select all of these together and let's attach our harvestable component to these. So we have all of these connected to our harvestable component. Let's save it and let's press play to double check our behavior. So if we check, now we are successfully harvesting our resources, but it's not harvesting them fast enough to actually patrol. So we don't see it actually moving to collect and start patrolling. So let's increase our respawn time to say something like 20. And let's also increase our move speed to something like 100. So it's going to gather really quickly and we're going to have a longer respawn time for our resources. So let's press play and see how that works. And it looks like we are gathering them much faster now. So we've collected all of them, and now that we've collected them all, it's gonna start patrolling. So it's beginning to patrol, and there it goes. And hopefully we can see another resource spawn in, and now that we've spawned it in, it's gonna start collecting these resources in, and then it's gonna almost patrol, collect the rest of them, and then start patrolling again. So this is our finalized behavior. So this is going to be our trees that we've crafted. And essentially we've done basically the same thing that we've done in our simple tree. However, this allows for a more customized way to utilize our behavioral nodes and create our own versions of our BT node with our different way of coding. So both accomplish very similar and nearly identical things. However, I just wanted to show you guys the flexibility of our AI system so that you can create your own behavior, create your own programming patterns, and develop in the way that you feel is best. That's everything that I have for you in today's video. Thank you so much for joining me, and I can't wait to see what you guys can do with AI.